Hello class, greeting, welcome back to our class. We are looking at the topic, the cause of motion. But before we go to the cause of motion, let's have a little review of what we have done in the previous lesson. We have already defined motion as change of position of an object or body with respect to time. Motion also involves movement of an object with respect to time. That is to tell you that whenever you are defining motion, you must mention time to make your definition more accurate. And also we went further, we look at types of motion, where we look at random motion, circulatory motion, vibratory motion. We also look at relative motion. Now, we want to look at the cause of motion. What makes a body at rest to move? And what makes a body moving in a uniform straight line to change direction or to stop? That is because of motion. That is why we look at force, the cause of motion. So it is force that makes an object to move. How do we define force? What is force? Force is defined as the agent that changes or tends to change the state of rest or uniform motion of an object in a straight line. Force is also defined as the product of mass and acceleration. What then is the unit of force? The SI unit of force after calculation is Newton. We are supposed to use Newton since Newton is the international acceptable unit. Also, we can write it as kilogram meter per second square, since mass is in kilogram and acceleration is in meter per second square. That's the correct unit. So we look at the effect of force. Force is a very complicated word, but however, we can see the effect of force. Force number one can change the state of body at rest to move. Force changes the speed of an object. That is to say that when we apply force to a moving object, we can increase the speed of the object. By the time we reduce the force we apply, that means we are slowing down the what? The force. Also, force changes the direction of the motion of an object. When an object is moving north, we can change its direction by applying force to move in either south or west. Number 4, force can stop a moving object altogether. That is to say that when a body is accelerating, we can apply force and stop its motion and make it to be at rest. Now we look at types of motion. We have two major types of motion. That is, number 1, we have contact forces, and number 2, we have what we call force fields. Contact forces. What are contact forces? These are forces that has to do with contact or with touch with the body to which they are affected or applied. Contact forces, these are the forces that has to do with contact or with touch to the body which they are affected. Examples are the force of pull, push, tension, reaction, and frictional forces. These are the examples of contact forces. The second type of force is force fields. These are forces whose sources do not require contact with the body to which they are applied or affected. That is to say that their effect is from a distance and yet their action is being seen. Example of those forces are, we have gravitational force, we have magnetic force, electric force or electrostatic forces, etc., etc., or others. These are the two types of forces. So class, we have just defined force as an agent that changes or tends to change the state of rest or uniform motion of an object in a straight line. We also say force can also be defined as the product of mass and acceleration. And the SI unit of force is Newton. We can also use kilogram per meter squared. And we say that force has the following effect. Force changes the state of rest to motion. Force changes the speed of an object. That is to say, it can slow it down, it can also increase the speed of a moving object. Number 3, we say force changes the direction of a body, where we say if a body is moving in north direction, it can be altered or changed to move in east or south. Number 4, we say force can stop a moving body altogether to be at rest. And we also consider the types of forces, which we have the force contact or contact forces, and then the force field. We define contact forces as those forces that has to do with contact with the body to which they are applied. Example is frictional force. Another example is push or pull, etc. And then the last one is force field. These are forces which do not have to do with contact with the body to which they are affected or applied. Example is gravitational force, electric force or electrostatic, etc., etc., or others. Thank you so much. Stay in tune for the next class. Hello class. We are back again to our lesson. In the previous lesson, we look at force as an agent that changes or tends to change the state of rest or uniform motion of a body in a straight line, where we also stated two types of motion, two types of force rather. We say we have the contact force and the force field. We say contact forces are the forces that has to do with contact or with touch with the bodies to which they are affected or applied. One of the examples we give under contact force is frictional forces. That is why now we are looking at friction as our subtopic now. Now, how do we define friction? Before we define friction, we know that when solids, two solids, are brought together, the roughness of their surfaces prevent them from sliding freely or moving freely one over the other. That is due to effect of friction. We define friction as a force which acts at the surface of separation between two objects in contact and tends to oppose the motion of one over the other. That is to say, friction is the force of opposition. It acts in opposite direction with the force we apply to move. So we look at static and dynamic friction. Under static and dynamic friction, now we can observe the effect of friction by attaching a spring balance to a block of wood and pulling it with a force. That is to say that pulling the spring balance with a force so that we can see the effect of the friction. When we put it on a normal table surface, that spring balance, we attach it with the wood, is going to give us the reading of the frictional force on the surface, frictional force on the surface of the wood. So we look at this figure. As you can see, this is a wood, this is a spring balance, and it's being pulled on a very smooth board. When you pull this wood, you are going to see the reading on this spring balance. A spring balance, it is an apparatus that we use to read the force of an object that has mass when it's being pulled. So this spring balance is being pulled by a force. There is a force here, F. And also there is another force here, capital letter F. This is small letter f. This is a frictional force. As you are pulling it this way, the frictional force goes in another direction. That is to tell you that in that surface, the frictional force is acting in opposition or in opposite direction to the normal force which is being applied. Now you look at reaction. This is reaction. The action is working directly in opposition to the weight of an object. When there is mass of object, there must be reactive force or reaction, that is R. So in that case, we can study the frictional force, where we can get the static or limiting frictional force. Now, static or limiting frictional force, by the time you start moving this object, when the body just starts to move, as it starts to move, then we see the reading of this spring balance is going to show. That is what we call static or limiting frictional force. How do we define static or limiting frictional force? This is a maximum force that must be overcome before a body can just start to move over another body. That is what we call static limiting or limiting frictional force. Now the next one is dynamics friction. This dynamic friction, when you make the body to move, there is a frictional force you must overcome so that the body will keep moving in a uniform straight line. That is, we are overcoming what we call dynamic frictional force. This is a force that must be overcome so that the body can move with uniform speed over another body. That is to say that the body is moving in a straight line without any moving in another direction. That means the body has what we call uniform speed. From there, we look at laws of friction. We have about 5 laws of friction. Number 1, friction opposes relative motion between two surfaces in contact. As we say, there must be opposition between two bodies. Relative motion, the other one is the force you apply, and the other one is the frictional force. So they oppose each other. They have what we call opposition between their surfaces in contact. Number 2, the force of friction increases to the same extent as the force we tend to start the motion. There is a force you apply to make the body move, and then there is the frictional force that is opposing it. The more you increase the friction, the more you increase the force, the more the frictional force also increases. That's why we say the force of friction increases to the same extent as the force we tend to start the motion. Number 3, we say frictional force depends on the nature of the surface of an object. Now, we have different types of surfaces. We have rough surface, we have polished surface, we have also slippery surface, and we have polished surface. These are the surfaces that can affect the frictional force. Number 4, it is independent of the surface area in contact. That is to say that even if the area is small or big, if the areas are being brought in contact and they are being moved together, there will be frictional force. Then the 5th one is frictional force is directly proportional to normal reaction. Force F and reaction R. So F is equal to mu R. Mu is the constant. That is the next one we'll consider in our next class, so that we'll look at some calculation under this one. So far, class, we have defined friction, and we have already stated the static and dynamic friction. We look at this, we can study this static and dynamic friction with the use of a spring balance, where we can study also the limiting frictional force or static frictional force and dynamic frictional force. Don't forget, this dynamic frictional force is also called kinetic frictional force. We say this is the force that must be overcome so that the body will move in a uniform straight line over another body. We also consider the 5 laws of friction. Thank you so much. Stay in tune for the next class.